Earth Science, Chapter 1, Section 5, What is Scientific Inquiry? Page 23. Earth scientists, like all scientists, are guided by the basic assumption that through careful, systematic study, events in the natural world can be understood and explained. The knowledge gathered can be used to make useful predictions. For example, by understanding weather patterns, meteorologists can predict the path of a hurricane. The process of science. Scientific inquiry refers to the diverse ways in which scientists study the natural world and propose explanations based on the evidence they gather. The dynamic process of science involves observing, asking questions, developing hypotheses, making and testing predictions, and analyzing and interpreting results. Scientists take various paths using these scientific methods, depending on the questions they are investigating and the resources available to them. Developing hypotheses. Scientific inquiry often begins as scientists pose questions and collect data through observation and measurement. Scientists try to explain how or why things happen in the manner observed by stating a hypothesis. A hypothesis is a scientific explanation for a set of observations that can be tested in ways that support or reject it. Scientists often explore more than one hypothesis at the same time. A hypothesis must be rigorously tested and analyzed before it can be accepted by the scientific community. Testing hypotheses. Testing a hypothesis often involves designing an experiment that keeps track of various factors that can change, called variables. Examples of variables include temperature, amount of sunlight, and time. In a controlled experiment, only one variable is changed, while all other variables are kept unchanged or controlled. When experimental data does not fit with a hypothesis, the hypothesis may be modified or discarded altogether. An example of a discarded hypothesis is the Earth-centered model of the universe. Experiments are just one way that scientists test their hypotheses. Observational studies provide another key source of data. In an observational study, scientists look for evidence in the natural world that would help confirm or contradict the predictions generated by their hypotheses. You can learn more about scientific skills and methods, including science safety procedures, in the Skills Handbook in the appendix. Scientific knowledge. An important aspect of scientific inquiry is the sharing of ideas and communication of results to the scientific community. The scientific community, through critical review and replication of data, helps to verify the accuracy of results and contributes to the establishment of scientific theories. Scientific theories. In science, a theory is a well-established, highly reliable explanation of a natural or physical phenomenon. A scientific theory unifies a broad range of observations and hypotheses and enables scientists to make accurate predictions about new situations. Tested by multiple independent researchers, a theory is well supported by evidence and widely accepted by the scientific community. For example, the theory of plate tectonics provides the framework for understanding the origin of continents and ocean basins, plus the occurrence of mountains, earthquakes, and volcanoes. Scientific laws. Laws differ from theories. A scientific law is a concise, specific statement that summarizes a pattern found in nature. Laws describe how some aspect of the world is expected to behave in a certain situation. For example, the laws of planetary motion describe the way planets move around the sun. In general, laws describe relationships, but do not attempt to explain why the relationships exist. Similar to theories, laws are based on repeatable observations and are widely accepted by the scientific community.